Hey, think back to the last time you learned something totally new. Like driving a car or fumbling through a new song on the guitar. Remember that feeling? So clumsy, so slow, where you have to think about every single little step? Well, today we're going to pull back the curtain on the science of how your brain goes from that clunky, conscious state to just pure, effortless flow. We've all been there, right? You're trying to juggle a dozen new rules, your hands just won't do what you want them to do, and your brain feels like it's about to just fizzle out. It's that moment of total overload where you can't help but think, man, I am just not getting this. Well, I've got some good news for you. That feeling? It's not a personal failure. It's not a bug in your system. It's actually a feature of how you're wired. Your brain has this fundamental limit, a bottleneck, that every single one of us has to learn how to navigate. And here's the number that defines that limit. 4. That's it. Your conscious mind, what we call your working memory, can only really handle about 4 new pieces of information at any given time. That's the bottleneck, and it's the number one reason why mastering anything is a journey, not just an instant download. Okay, so let's dive into this. To really get how we work around this bottleneck, we first have to understand the system itself. A great way to think about your brain's memory is like a computer that has 3 very different kinds of drives. So this is the classic model for how it all works. First, you've got this flood of information hitting your sensory memory, all the sights, the sounds, the feelings. Then your attention acts like a spotlight. It picks out what's important and moves it over to your working memory. Now think of that as your mental desktop, the stuff you're actively working on. If you actually engage with it, your brain goes, okay, this is important, and saves it to your long-term memory, which is like this vast, almost infinite hard drive. Let's really zero in on that working memory because it's the star of our show today. It's where all the magic of conscious thinking happens, but, and this is a huge but, it's tiny and it's super fleeting. Anything you put there vanishes in about 30 seconds unless you keep actively thinking about it. This right here is the bottleneck we've been talking about, and it's the central challenge in all of learning. And this just nails the whole point of practice, doesn't it? I mean, if our working memory was infinite, we could learn anything instantly just by reading the manual, but it's not. So the entire process of getting good at something is really just your brain's amazing workaround for this one fundamental limitation. So how does the brain actually pull off this workaround? Well, it turns out it follows a pretty predictable 3-stage journey that takes us from a fumbling beginner to an effortless expert. A couple of guys named Fitz and Posner mapped this whole thing out way back in the 60s, and it's still the foundation for how we think about this today. You start out just trying to figure out the rules, right? The what do I do phase. Then you practice to get better and refine your technique. That's the how do I do it better phase. And finally, if you stick with it, the skill becomes so second nature, you can do it without even thinking. That first stage, the cognitive stage, is all about pure conscious effort. You're using what scientists call declarative knowledge, facts and rules you can actually say out loud, like, okay, first press the clutch, then move the stick. This stage just completely maxes out your working memory, which is exactly why your performance is so slow, so clumsy, and full of mistakes. After that, you move into the associative stage. Here, the question in your head changes from what do I do to how can I do this better? This is the real practice phase. You're smoothing out the rough edges, connecting the dots, and making the whole sequence more fluid. Your brain is literally building and strengthening pathways, and you start to rely less and less on those conscious rules. And then, finally, you hit the jackpot, the autonomous stage. The skill is now automatic. It's shifted from facts you can state to what's called procedural knowledge. It's this deep physical how-to that you can't even really explain anymore. You just do it. And the best part? The skill requires almost zero conscious attention, freeing up that brain bottleneck to focus on other things, like strategy in a game or having a conversation while you drive. So what's the actual mechanism here? What's the secret sauce that powers this incredible transformation from clunky thinking to smooth, automatic action? Well, the answer lies in a concept that is basically your brain's ultimate productivity hack. It's something called a schema. A schema is essentially a mental shortcut. The best analogy is a zip file on your computer. You take a whole folder stuffed with related files, and you compress it into one single tidy little package. Your brain does the exact same thing, bundling huge, complex sets of actions and knowledge into one easy-to-grab unit. And this, right here, just shows the power of a schema perfectly. Look at the novice driver's brain.
It's using up all of its working memory just to change gears. Every single one of those steps is a separate item. But for the expert, all of those steps have been compressed. They've been zipped up into one single automatic schema: change gear. So here's the absolute crucial point, the big takeaway. Building schemas is how we cheat the system. It's how we bypass that bottleneck. A skill that once took up all 4 slots in your working memory now only takes up 1. This is what expertise actually is at a cognitive level. It's not about having a bigger brain. It's just about having better organized knowledge.
Now, this whole process of building schemas, which is often called chunking, is how we make skills automatic. But while this nice, clean 3-stage model is a great map, the actual territory of learning, well, it's often a bit messier. And anyone who's ever really tried to learn something knows this feeling deep down. The journey is not a clean, straight line from A to B. It's full of hills and valleys and some really frustrating detours that this simple model doesn't quite capture. The reality is, learning is super nonlinear. You'll have these amazing bursts of progress, and then you hit a wall, a long, frustrating plateau where you feel totally stuck. And have you ever had a skill just fall apart when you're under pressure? That's your brain getting overloaded and temporarily going backward, forced to rely on those slow, clunky step-by-step rules from stage 1 all over again.
All this complexity has led some scientists to ask a really different kind of question. What if the secret to skill isn't just what's going on inside our heads, but in the constant dynamic dance between us and our environment?
And this question gets at a really interesting debate happening in the science of learning. The cognitive view that we've mostly been talking about is all about what's inside your head, building those mental zip files, those schemas. But this alternative, the ecological view, argues that skill isn't some program running in your brain, but more like an active dance between you and the world around you. It sees learning as way more dynamic, a real-time process of adapting on the fly.
So, where does all this leave us? Well, the debate between these views is still going on. But the cool thing is, if we combine the insights from both, we get some really powerful, practical tools we can use to become better learners, like right now.
All right, here's your toolkit. First, manage your cognitive load. You have to respect that 4-item limit. Break skills down into small, manageable chunks. Second, use variable practice. Don't just hit the same golf shot 100 times from the same spot. Practice in different conditions, different lies, different clubs. This builds a skill that's flexible and adaptable, not brittle. And finally, and this one is huge, shift to an external focus. Stop thinking so much about how your elbow is bent, instead focus on the outcome, like the flight of the ball. This simple little mental shift helps your automatic brain take over from your overthinking conscious mind.
You see, once you understand the architecture of how you learn, it kind of demystifies the whole process. It's not magic. It's a predictable journey of managing a bottleneck, building those mental shortcuts, and adapting to the world around you. So the only question left is, what are you going to apply it to?